We now have the tools to solve the problem we introduced in the opening of the section. An airplane is flying at an airspeed of 200 miles per hour, headed on a southeast bearing of 140 degrees. A north wind, from north to south, is blowing at 16.2 miles per hour. What are the ground speed and actual bearing of the plane? Well, hopefully you have your notes beside you. Keep that handy so you know what the words are, but I blew up the picture so we could see it just a little bit better. Okay, so what all are they telling us in this picture? They told us that the airplane is traveling at 200 miles per hour. They also told us that the wind, so the wind is blowing this airplane from north to south. That's what this is right here. It's blowing from north to south at 16.2 miles per hour. Okay, so we have this little triangle forming here. And they told us that this is a 140 degree bearing. Okay, so this is north. And this is going from north to south. So actually, you have, I need a bigger straight edge here. Hopefully this is parallel. We'll see whenever I get it drawn on here. What I want you to see is that this line and this line are parallel to each other. Okay? So how does this help us at all? Well, we know that this angle is 140 degrees. We know that this line is cutting two parallel lines, which means opposite interior angles are equal. That means this angle right here is also 140 degrees. I know that's really tiny, but the angle C right there, this angle is 140 degrees because alternate interior angles are equal. Now this makes you remember stuff from way back in geometry, so hopefully you remember that at least a little bit. Well, now that we know that that's 140 degrees, what else do we know that could help us solve this problem? We know this side, we know this side, we know the angle between them. We're looking for where the airplane is actually moving. That's this green line right here. So if we know two sides and the angle between them, can't we use the law of cosines? Okay, let me switch back over here to the other page. The law of cosines. Now, what did that say again? If you need to go back and look it up, you're welcome to, but I am going to write it down for us. So it's telling us that x squared, this side, is equal to BC, that's that tiny little side, so BC squared plus the other side squared, that's the 200. We'll call that OC, OC squared, minus 2 times the two sides, BC and OC, times the cosine of the angle between them. That angle from where I showed you on the big picture was 140 degrees. Let's type all of this into our calculator and see what we get. Oh, I guess I need to put numbers in there, huh? So this is equal to BC, which is 16.2. OC is 200. Okay, now we can plug it in the calculator. 16.2 squared plus 200 squared minus 2 times 16.2 times 200 times cosine of 140. I think that's right. We get this crazy big number. So x squared is equal to 45,226.40799 something. Okay, well, I'm going to store that. I'll make a little note here that says store in x. You don't really have to do that, but how do you solve for x, this x? We take the square root of this number, right? So x is approximately equal to second square root of that number is 212.7. 212.7. Well, what does that mean? We said x was 212.7, right? That's this side. So this is 212.7. That is the magnitude of the side. So that's how fast the airplane is actually flying. 212.7. Why is it faster than what it says it's flying? Because the wind is pushing it, right? It's not only pushing it faster, it's pushing it south more. Okay, so what else are we looking for? It says, what are the ground speed and actual bearing of the plane? Well, we have to figure out what else we know that can help us answer that question. We want to know what the bearing is. The bearing would be this angle plus this little tiny angle right here. We know this side, this side, this side, and one angle. Can we use the law of sines to find that angle? If we use the law of sines, we have sine of, we're going to call this angle alpha. At least they called it that already. So the sine of alpha over, keep having to go back. So the side opposite angle alpha is the 16.2 side, right? Sine of alpha over 16.2 is equal to, go back to the picture. We know this angle and this side, right? So we could do sine of 140 over 212.7. Okay, let's solve. So we have if we cross multiply, 212.7 sine alpha is equal to 16.2 times, I just totally did that backwards. No, I didn't. Times the sine of 140 degrees. Sorry about that. Multiply these two, multiply these two. Divide both sides by the 212.7 to find out that sine of alpha is equal to something. Let's see what it's equal to. We get 0.0489 something something something. 0.0489 blah 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 blah. Whole bunch of stuff. We need the inverse sine to figure out what alpha is. So inverse sine of our previous answer is 2.8. Now, what were we looking for just now? We're looking for this tiny little angle right here. That tiny little angle is 2.8 degrees, right? They want to know this bearing. So wouldn't it be the 140 plus those 2.8 degrees? All right, let's call that angle beta. So on here, all the way to there would be called angle beta, all the way around. That's going to be the original 140 degrees plus that tiny little angle that the wind is pushing us, and we end up with 142.8 degree bearing.